lot of you were in the last session with Christian where you got kind of a higher level overview of the overall project. This is the hands-on demo component of it. Today I'll be presenting with Jacob and Sai, and I'm Carla. So hopefully some of you, I noticed, so on Docker Hub you can see about how many people pulled your Docker image. So we know at least 10 people have downloaded the Docker images, so that's good. I guess if you don't already have Docker or Docker Compose installed, it might be kind of hard with the Wi-Fi issues. It seems like some people are successfully connected right now. I'm tethered to my phone, so hopefully my phone Wi-Fi holds out for the demo. I guess we're going to be also doing the demo on our screen so you can at least see it, and it's all posted on GitHub online. So if you can't follow along with the demo now, everything is available and you can do it at home later. First, Jacob's going to talk a little bit more, just in case you weren't in Christian's talk earlier, about an overview of the EPC, our NGIC project background, and then the demo.
Thanks. So here we have just a basic network architecture. You have the control and user planes. And you have three interfaces that exposes three GPP defined S11, S1U, and SGI. So for our hands-on demo, we're going to have three different containers. You have control and data planes in their own, and then we're going to be simulating network traffic with TCP replay on each interface. Okay, so I'll give a little bit of a brief overview of the source tree structure. You have the config directory, which will have a series of configuration files. You have the CP and DP config, which will identify your S11, SGI, and S1U IPs, MAC addresses. ADC rules, which will allow you to configure ADC rules, as well as PCC rules in its own file, and then metering profile configuration, and then finally a CDR configuration file, so you can save your CDR file wherever you want. Within the control plane directory, you have the control plane code, obviously. Most important files there would be the UE.c and H file, which defines the state and controls the state of the actual control plane. And then within this GTP v2c messages directory, you will have the parsing and the creation and handling of all the state within the UE.c and H files. And then you'll also have the run script that will populate all the DPTK arguments that are required. Within the CPDP API directory, you have a couple of files that will define the messages passed between the control and data planes, and we have docs in the docs directory documentation. So within the data plane, you have a series of lookup tables, and each one of those is within their own file, with the exception of ACL, because we use ACL tables for two different lookup stages, one being the ADC rules and the other for the just general PCC rules for the bearer mappings. Then we have CDR for charge data records, metering as for metering, and then within the pipeline, for each one of those pipeline stages, we have its own file to define how those pipelines actually attach to each other. Then you have the packet handler that actually does the packet walkthrough, which I'll talk about in a moment, and then a run script. And then finally, we have a library that's and that does DNS snooping, which uses Intel's Hyperscan library. Okay, so just a brief packet walk for the data plane. You have multiple worker cores that are load balanced based off of RSS, or I'm sorry, that are load balanced based off the UEIP. So as packets come into the system, they hit the load balancer for both SGI and S1U, and they either go uplink or downlink on whichever worker core. So. And as I mentioned earlier, that the packet handler functions, there's one for uplink and one for downlink.
Okay, so that's the basics of what's going on with the code. The code is actually available. It's posted on the Jarrett Open Code website. The demo that we're working with today, the Docker images were built off of this specific commit ID. The build does take a little bit, maybe 15 minutes or so, a little complicated. Depends. Anyway, the point is we have 45 minutes or about, I guess, 20 minutes now, so we pre-built them for you. So those of you that are following along with the demo and have this pre-installed, go ahead and open up 3 terminals and change directories to the demo folder. Okay, so I'm going to exit the presentation mode. Okay, so also for the purpose of copying and pasting instructions, I'll be copying and pasting them from the PowerPoint, but if you're following along, the GitHub website has all of the demo instructions here, the prerequisites. So if you have this link up, hopefully you can see it, it's the NGIC core demo / core build 2017. The first thing we're going to do is start the data plane. So we're going to be, as Jacob mentioned earlier, we have the 3 separate containers that are, so we have the control plane container, data plane, and then this is basically emulating our traffic. So this is going to be just replaying pcaps using TCP replay. The first container we start is the data plane. It's going to set up, once it gets started, we can connect to the control plane, and then once that's all set up, we'll start the traffic. So again, for those of you following along, in terminal 1, so we're going to start the data plane. How's this look? Hey, not bad. Okay, so as the data plane starts up, you can see it printing a lot of output. Do you have any comments to add, like what we're looking at?
So most of these, most of this output is just DPTK specific output. So it's starting up number of cores and allocating memory and so on and so forth. Nothing much is interesting.
Okay.
Identifying which NIC is S1U SGI. Just doing all the basic startup procedure.
Right. So if we have 3 different NICs in that situation for the data plane, we have, the data plane 3 NICs that, like he was saying.
Well, there's 2 on the data plane. That S1U and S2.
2 on the data plane, and then the interface between the control plane.
All right.
So yes, the 3 NICs. Yes. Okay. So that is set up. And then the next thing we do is we start the control plane, and we know that the data plane is ready to go. It prints the table not set up. It's waiting for the control plane to connect. Okay, so that instruction is just bringing up the Docker image, Docker Compose. How many of you are familiar with like Docker Compose or Docker? Have used it before? Okay. So yeah, the Docker Compose command, the EPC is the name of the project, and then we're bringing up each container one by one. So CP is the name of this container. Okay, and as the CP slowly comes up, it's doing some stuff with packet filters, and then eventually it'll start printing stats about what message it has received on the S11 interface, the interface to the control plane. We'll give it a minute there. It seems, there you go. So I made the font really big because I wanted everyone to be able to see it, but basically you see in the center, this is kind of like a timestamp, or where time 0 is where we start. So it's been running for 18 seconds, and the zeros, there's a bunch of table headers. If you're following along, here if I can.
Sorry, I missed that. Are actually the EPC components like server gate, the packet gateway, they're containerized, or are they in VM?
Yeah, everything here is completely a container, so no VMs involved. So that way it makes it a very fast demo, and then be able to bring it up very fast. Because I made the font large, it's hard to see, but basically the columns are packets received, packets transmitted, and then some stats on the type of packet that we've received. Okay, let me go back down to the bottom of the input. There we go. Okay. Okay, yes. And I think that might be frozen too. Ah, yes, okay. Maybe I'll make the font smaller then, since it's under. Okay, somewhere in this massive output, it printed that the control plane connected. Ah, yes. So here, where it says MTR profile add, that's showing us that the control plane has been connected with the data plane, and then we have a lot of output here, various ring buffers that are going on in the data plane, separate.
It establishes the tables and initializes those tables with lookup values.
Yeah, and yes, and so the two main things we're looking at today are there's this stats for the S1U port and the SGI port, and the basic things to look at are whether we've received or transmitted. Right now, I guess there's kind of some noise in the background, but no real packets have been sent yet. All right, so now that the control plane and data plane are up, I'm gonna make this, well, you'll be able to see packets. Hard to mix you guys being able to see it with having all the input displayed at once. All right, so now it's time to start the traffic container. We'll bring up the traffic container first. And the traffic container is just a really simple, pretty much empty. We've worked with a lot of cool traffic generator tools such as Spirit and NGIC, but this is just simply replaying recorded traffic. And it's just straight up Ubuntu clean install with some additional packet utils like TCP replay installed. So then that brought up the VM, and to actually go into the container, we say docker exec, and we're just going to bring up a shell. So docker exec into the traffic container, bring up bash. So now we have a shell into the container. Notice that the host changed from the stack machine to the container. In the pcap directory, everything should be mounted. We have these 3 pcap images for the 3 different things we need to replay. The first thing we need is the control plane traffic over the S11 interface, which is going to set up the connections and push the rules for our data. Okay, so this is, as we mentioned earlier, there's 3 different interfaces. It's kind of tricky with Docker because it doesn't, we found when we were making the images, one of the problems, going back to the container brigade from a few days ago, people asked what challenges we had in porting this to Docker. The biggest challenge was a lot of the networking thing there. Because we require 3 separate network interfaces and we're bringing them up at a specific IP address, it's hard to map the interface name to the IP address. It's random each time, it seems, so it will assign a different name to the IP address. In order to be able to run our tool, we need to know which maps to which, so we make sure to play the S11 traffic over the correct interface. So that's what this step is setting up here. Obviously, you can't type this off the PowerPoint, and so if you happen to still be following along, you can just paste it in the README file in the code directory. So in the directory that you cloned from GitHub, if you just cat the README file or see the README file, this longer thing to paste in now. Basically, the rules. What we're doing is we're grepping to see what interfaces names map. So pasting that into the traffic container. Okay. So now if I basically, that was just a simple command to say which, so now we know that the S1U is mapped to ETH2, for example. So that's why that step's necessary. Okay, so how are we doing? I see a couple, there's at least 2 people following along, so. Okay, good, all right.
So can you be more explicit, like this IP assignment? Are you using namespace for the networking part, or others?
I mean, this is nothing, it's basically just we need to know which maps to what when it brought up. So when you tell Docker, I need 3 network interfaces, there's no way of knowing what they were named, and we need the name of it, like we need the name ETH2 or ETH1 to be able to issue the TCP replay commands. So it's just a simple matter of, I think a lot of the use cases for Docker don't involve like 3 separate network interfaces and needing the names, so. Okay. So now we can actually start the traffic. So this is just a simple TCP replay command. It's going to read from the pcap file of the pre-recorded S11 traffic and replay it at 200 packets per second. It's a total of 2,000 messages. This is a create session message, which is setting up a new session, and then modify bearer messages, which is in the same replay. So this is the control plane. You can see that we told the replay to send at 200 packets per second. So you can see it's transmitting and receiving 200 packets per second. And again, the log that Docker is displaying is a little bit delayed and kind of jumpy. But so now we can see that all 1,000 create session messages have been sent and 1,000 modify bearer. So yes, so far so good. My phone-based Wi-Fi is holding up well. So now we're going to do the data plane traffic. I'm going to just go back to this previous screen because if you haven't stared at it a million times, it can be a little bit. So where we're at right now is we've started the control plane container, data plane container, and then our replay container. So far what we've done is we've kind of emulated an MME by replaying the S11 messages. So what we need to do now is start the data plane traffic. So that's the S1U, emulated to the eNode B, and then the SGI, which is emulated to the internet. All right, S1U. Going back, so right now the data plane still has 0 or roughly 0 packets. So generating some replaying some S1U packets. We go back to the data plane, and when that screen refreshes, it did. You see that we have on the SGI, we've sent some packets, and then on the S1U, we received. And then in the other direction, so now for the SGI, In the traffic container, we're going to enter that replay command, send that out, which is, I guess, eth1. And then shortly in the data plane, we should see the opposite direction populate. It seems to be about a 15-second delay or so for just the Docker log to catch up. Okay. Well, there's the first part of it. There you go. Okay, so that shows that traffic has been sent and received in both directions along the data plane. And that's the basic demo, just sending traffic across the interfaces. To exit, and remember this is just a standard Ubuntu, so we can just exit out of that. And then we use Docker Compose to tear down all 3 of the containers at once for their EPC. And then that shuts down all of the different containers. So yeah, that's the basics of it. Again, I know a lot of you couldn't follow along today, but we have all of the steps documented here on our GitHub website. Another thing I wanted to point out, since this is all about open source, since they're pre-built Docker images that might be a little unsatisfying. So if you'd like to build the Docker images yourself, we provided the Docker files as well. And so all you have to do is clone. So all of the code is available here. The link is available. You need to just pull it at that specific commit, because that's what we've tested it with. So we want to make sure to stay consistent. And then we had to apply a patch for static arps, because we're doing TCP replay rather than using a real MME. We have to install the arps statically, but that's the only modification that we needed. Everything else in the Docker containers is our source code. All right, so that's pretty much the demo. I was wondering, any questions or?
This was running on a single server, all of this?
Yes, so this was running on my Linux box back in Oregon. You can run it on, we tested the Docker images on both Mac and Linux. And also we ran it on some pretty old crufty laptops. And so it's kind of exciting to think that you have, a cellular core traffic emulation running on your laptop. So. All right, if there are any other questions? All right, well, if you didn't get to play along today, make sure the directions for the setup are on the web page, and everything is online, so you can go back and tell your friends. All right, thank you very much.
Talk a little bit more about how, like on our laptops, we're just generating traffic, not using like special Intel NICs, and on a server you have special Intel NICs where you can run DPDK. Like how that configuration happens in the various environments.
What type of configurations are you talking about?
So, like for example, like on a Mac or whatever, like I'm not necessarily using. I'm not using a special NIC.
Oh, you mean how do you have DPDK running on any NIC? Or you mean how do we get DPDK working on any other NIC? Or
I understand that you can run like DPDK against an arbitrary whatever beat pair or whatever they're spinning up. But how do you say like in my server environment now I actually want to map like my real NICs into the container rather than the bridge NICs?
I don't think you guys had to change anything to get this running with containers, right?
Yeah, no, we didn't change anything.
Yeah.
So
same container images to run in the server, then you need some modifications to the config where the run command is. So instead of saying use the AF packet interface, you need to say the PCIe ID of your and that should. And because it is a config file, you can just give your own config file and you can rebuild it.
But it's just whether or not it's one interface as opposed to another.
Yeah.
So,
Interfaces
Or
or
bind it to user space and
All right.
Are these slides available? The slides you have up, the slides can be shared.
Oh, I think we sent them to David. I think they're uploading everything as far as I know. So, oh. Well, everything from the slides is on the GitHub page pretty much, so should be good. All right, thanks so much for coming. I appreciate it.